morning student. Our next experiment is star to star connection. So you remember here this is the practical way of connection for star to star. So this is also a star and this is also a star. So here this star we are connecting for source and this star we are going to connect for load. Okay, then here you remember a few points about star to star. Okay, so it's mean a very simple theory. We need to understand phase current and line current both are the same in star to star for both the ends, and phase voltage and line voltage is completely different in star connection. So the star connection phase voltage is equal to line voltage by root 3. Okay, then practical way of diagram here. So this is the practical way of diagram for a star to star connection. So already I have done how to connect this star connection practically in control panel. Okay, both star and delta how we are going to connect in control panel already I have done one video. So if you want to know the connection way of connection of star and delta, so you have to visit that video. I'm going to give the link. I'm going to give the link given below description. Okay, so this is the star to star connection actually. So here star source also a star and load also a star. Here we are going to take 2 wattmeters. Okay, for R phase and B phase we need to measure the power. So W1 wattmeter and W2 wattmeter, and we are taking 1 voltmeter in between R phase and Y phase. This one is a line voltage measurement purpose only we are taking this voltmeter. The same thing here also in load side also we are taking 1 voltmeter in between R and Y load. So we are measuring here line voltage. Okay, this ammeter is useful to measure the current in a Y phase. Okay, so this is a star to star connection. This one is a balanced type of connection. So that's why we are measuring in between 2 lines, 2 phases. We are getting line voltage, no? So that line voltage is same in all the phases. Okay, and current also same in all phases. So just like we are taking only 1 ammeter to measure the one phase current. So remaining 3 phases also same current is there. Okay, so here also same. We are taking 1 voltmeter and 1 ammeter and 2 wattmeters. Okay, you remember. So star to star balanced type of connection this one. So that's why here we are taking only 1 voltmeter and 1 ammeter, and voltmeter is line voltage measurement and ammeter is phase current measurement. Okay, so ammeter we are taking in series and voltmeter we are taking in parallel in between R and Y phase. Okay, so this is a star to delta connection. So at source end I have connected star connection and at load end I have connected delta connection. Okay, so as well as we have a different types of connections, no, star to star and delta to delta and star to delta and delta to star, no. So if we need a star to star connection, in the sense the same source side star connection we are connecting at load side also. If we need to connect a delta to delta connection, in the sense at load end delta connection is connected at source end also, then that one is a delta to delta connection. If we want to take a delta to star, in the sense at source end we can connect a delta connection and load end we are connecting this star connection at load end. So these are the different types of connections. So here this one is a star connection. So here we have a this one is a three-phase power supply, AC power supply. That one is 440 volts, and this one is a indication of variac. By using this variac, we need to vary the voltage up to 440 volts, three-phase. And here we have a 4 watt meters. So this one is a wattmeter 1 and this one is a wattmeter 2. In delta connection also we have a wattmeter 3 and wattmeter 4. And as well as here we have at source end 1 voltmeter in between R phase and Y phase. So because voltmeter always we are connecting at parallel only, no? So that's why we are taking R and Y in between R Y phase we are taking 1 voltmeter. And for Y phase we are taking 1 ammeter. So ammeter always we are connecting in series only. So as well as we need to take for R phase and B phase also ammeter. But here this one is a balance, 3-phase balance power supply. No? That's why, so in all the phases same current only. So that's why I have taken only 1 ammeter and 1 voltmeter. 1 voltmeter in between 2 phases. So it's mean this one is a line voltage, okay, and this one is a ammeter for a Y phase. And here we are taking a 1 wattmeter for a B phase and another wattmeter for R phase, okay. And as well as here also we are taking for R phase 1 wattmeter and B phase 1 wattmeter. And here also we are taking 1 voltmeter in between 2 phases, like R phase, in between R phase to Y phase. So this voltmeter is range is 0 to 500 volts, okay. And 1 ammeter we are taking in series with Y phase, so that one is 0 to 20 amps. But here the ammeter range is 0 to 10, but here we are taking ammeter range is 0 to 20, because the reason is very simple. In star connection is a open loop system. That's why in open loop system voltage is high, current is very less. That's why less range ammeter we have taken. But delta connection is a closed circuit system. Just so in closed loop system current is very high. That's why we are taking here ammeter range is high range of ammeter, same like wattmeter also. So in open loop system in a star connection we are taking a 5 amps 500 volts UPF wattmeter. But here in a delta connection, so here current is very high, no? That's why we are taking here 20 amps ammeter and 500 volts UPF wattmeter we are taking. So here the range of wattmeter and ammeter we are taking high range compared to star connection, okay. So you remember always in star connection is simply a open loop system. That's why here in open loop system voltage is high but current is less. That's why high range current meters only we are taking in star connection. In delta connection is a closed loop system. That's why here compared to voltage current is very high. So that's why we are taking high range of ammeters we are taking always in delta connection. So you have to remember this one is a very important point, okay. So then we will go for practical connection and observation of practical values. Here you remember in our control panel, so we have only voltmeter and ammeter for a primary, and another voltmeter and ammeter for secondary side. But here there is no any wattmeters in this particular panel. So because of that, here we are not going to connect the wattmeters, okay. So if we want to take a power values also, in the sense we need to connect external wattmeters, okay. First I am going to connect the circuit without wattmeters, okay. Then after that I will be going to connect the external by using the external wattmeter. I will shows the power also at primary side and secondary side also, okay. Why? Because in our laboratory into star to delta and delta to star and star to star, delta to delta connection. We have a tabular column only for primary side line voltage and phase voltage, and secondary side line voltage and phase voltage, and voltage ratio only given in tabular column. So related to that, here by using this control panel we need to take only line voltage and as well as phase voltage only. Okay, so that's why I will not connect the wattmeter in this particular panel, you remember here. So first we are going to connect the star to star connection we are going to connect. So it's mean at primary side I am going to connect the star connection, and secondary side also I am going to connect the star connection. It means source we are taking a star connection, and load also we are going to take star connection. So such kind of connection I will be going to connect here, you remember. So star to star is always a secondary terminal is connected for second phase of the second terminal, and Y phase second terminal is connected for B phase second terminal. So this is a star connection, and the same star connection I am going to connect at load end also, you remember here. And the first phase second terminal is connected for second phase second terminal, and second phase second terminal is connected for third phase second terminal. So here primary side I have connected star connection, and the secondary side also I have connected star connection. So you simply remember our first terminal of the first phase first terminal is connected for first phase, and Y phase is connected for here first phase of the first terminal of primary side, and B phase of a source is connected for primary side B phase first terminal. Then I will be going to connect the neutral point here. So the neutral point always connected only for second terminal of all the phases. Okay, then primary side completed. The same thing I am going to connect here at secondary side. Secondary side first phase is connected for first load. Okay, and secondary side second phase first terminal connected for second load, and here secondary side third phase connected for load 3. Okay, and the neutral point of the load is connected here in a star connection only for second terminal of the secondary side. Okay, so first I have shown star connection at primary side and star connection at secondary side. Then R, Y, B, all three phases first terminals connected for source R, Y, B, and here load R, Y, B and neutral point is connected for secondary side R, Y, B, and neutral point is connected for only secondary side second terminal of the Y phase. Okay, so this is the way of connection. So here we are going to take line voltage and as well as phase voltage. So that's why I am going to connect one voltmeter across R phase and Y phase at primary side and as well as secondary side also. Okay, so this one is R phase first terminal. So R phase first terminal I am going to connect for voltmeter primary voltmeter. Here you have to remember, so voltmeter is there now, so that voltmeter R phase first terminal is connected for a voltmeter here, and the next same Y phase first terminal connected for voltmeter second point. Then this one is a phase voltage measurement voltage, and at the same time I am going to connect at a secondary side also. So here you remember primary secondary side R phase first terminal connected for voltmeter first terminal, and then Y phase first terminal, Y phase first terminal connected for say voltmeter second terminal, then completed. So we need to take a line voltage by using this voltmeter and this voltmeter at load end and this voltmeter at source end, but we need a phase voltage, in the sense any phase across R, Y, B at load end R, Y, B, any phase we are going to take one multimeter. So across only one phase, two terminals are there now for each and every phase. So across those two terminals we are going to connect one multimeter, in the sense, then we will going to get phase voltage. So this one is a phase voltage here across these two terminals of the R phase and Y phase and B phase. So any phase we need to connect two terminals of the voltmeter, we can get a phase voltage, but here we are going to take directly connected voltmeters only for phase voltages. Okay, that's it. Okay, we need to take a current values, in the sense we are connecting 1 ammeter at primary side and 1 ammeter at secondary side of the load side. Okay, then I will be showing that ammeter values and ammeter readings also. First you have to, according to our manual, so according to our manual we need only line voltage and phase voltage, that's why I have connected only phase voltmeters, and then we will going to take line voltmeters, then we will going to take phase voltages by using this multimeter. Then I will be going to turn on the power supply here. Then I am going to increase the source voltage by using the variac. The range of primary side is 400 volts and secondary side is 200 volts range, so that's why I am going to vary up to 400 volts only, but not exceeding 400 volts. Okay, so because the rating of the transformer is only 400 to 200 volts, so that's why I have varied. So primary side voltage we got 398, and secondary side you have to observe at load end 200 volts. This one is without load, without load, in the sense I did not apply any load here. Then I am going to turn on the load values. Then we got at primary side same voltage 398, but at secondary side when we can turn on the load, then we got only 191.7 line voltage. Okay, load end we got only 191.5 volts at load end, I mean to say that at secondary side. Okay, then I will be going to connect the ammeter also here at primary side 1 ammeter and secondary side 1 ammeter for this star connection. So you remember here we are going to connect here ammeter. So directly Y phase is connected for ammeter first terminal. So that's why Y phase I have connected here ammeter of first terminal, and the second terminal of ammeter, this one is a first terminal and this one is a second terminal. Second terminal of the ammeter is directly connected for Y phase of primary side. Okay, so second terminal of ammeter is directly connected for Y phase of first terminal. The same thing here also at load end also. Secondary side, here I have taken only star and star but not a star and delta. So you remember the same thing here also at load end. Secondary side load So you remember secondary side Y phase is directly connected for ammeter first terminal, and ammeter second terminal is connected for load point. Okay, that's it. Then we will be going to turn on the power supply. So after taking the 2 ammeters at primary side and the secondary side, then I will be going to vary the source voltage by using variac. By using variac I am going to vary the voltage up to 400 because the range of transformer is 400 volts. I am going to vary 300, 400 also high, and I have taken 394.6 okay at primary side. So without load we got here at the secondary side 199.2. Then I am going to turn on the load voltage. So you remember here without load, turn on the load, we got only secondary side ammeter value also 0 and primary side ammeter value also 0. Then we are going to turn on the load. When we